This is Mr. Long, and I'm going to go ahead and give a lesson on orbital diagrams, electron configurations, long and short, the Bohr model, and dot diagram. So we're going to use the periodic table, so please get your periodic table ready. Now, there are 5 terms that I want you guys to define, and you can define those first. You can put me on pause and define these, and then come back to where we are. So go ahead and pause me. Okay, I'm with my 3rd period class. Everybody say hi.
Hi.
Okay, and so we're going to start with the first element, which is hydrogen. So we're going to put an H here. And the atomic number, of course, is 1, meaning that it has 1 proton, 1 electron. And we're going to use these terms here as we plot our electrons in the orbital diagram. So we're going to go ahead and put 1 electron in the lowest energy, which is 1s, 1 or 2 and 2. What these mean is this is the main energy level. So the first number here in the 1s and 2s and 2p, those numbers are representative of the main energy levels around an atom. An atom can have 7 energy levels because there are 7 periods in the periodic table. So on our writing our electron configuration, we're going to read this like a book. And so we're going to write 1s1. Now these letters right here, they stand for the shape of the orbital where electrons are. And S is like a sphere, and P is like a dumbbell shaped. And P's can be, if you had like a little bitty graph, it could be on the x-axis, it could be on the y-axis, and it could be coming straight at you this way. So it's going to be able to hold up to 6 electrons. So we've got 1s1 for electron configuration. Now the Bohr model, well, hydrogen just has 1 proton, 1 lonely proton. So we're going to put them right there. And we're going to put 1 energy level around the nucleus of hydrogen. And we're going to put 1 electron. Now you might see an electron up here on top or on the side, but it really doesn't matter. It's the same thing. And for the dot diagram, we're just going to put the symbol of the element and the outer electrons. So that shows the electrons, the valence electrons, the electrons that an atom has to bind with other atoms. So hydrogen just gets 1. So it's all very simple. It's just the first one. But it does get more complex. Now let's take a look at helium. So helium is next, He. And atomic number is 2. Now I'm going to use a different orbital diagram. You'll find these 3 different ways. In the book, they do this. 1s, 2s, 2p. And you notice how they've lumped the p's together, that these are orbitals of equal energy. And the 2's mean they're still on the 2nd energy level. And s here means it's shaped like a sphere, p is shaped like a dumbbell. Okay, we're going to put in 2 electrons. 1, 2. Now, these are half arrows. You could very well put in a full arrow. It's just that when I was taught in college, my professor used a half arrow, so I've stuck with half arrows. And you can see them either way in chemistry tests or books, whatever. Now, you notice how there's only going to be 2 that occupy a line. A line is going to be an orbital, a region where electrons are located. And because we have 2, this is going to follow the Pauli exclusion principle, which states that only 2 electrons can occupy 1 energy level, and they have to be spinning in different directions. So this electron is spinning clockwise. This electron is spinning counterclockwise. Now this is not a 7, which sometimes people think about it, but this is an arrow, a half arrow, representing an electron. Okay, on our electron configuration, read this like a book, 1s2. So in the first energy level, in this orbital shaped like a sphere, there are 2 electrons. So electrons will be up here in the superscripts. Now for the Bohr model, we have 4 protons and neutrons. We'll put He there. And we're still going to have only 1 energy level, but it does get 2 electrons, and that's going to fill it up. And then on the dot diagram, we will have that, and you might see that this way, or you could see this that way, or you can see this way, or this way. The big point here is that these electrons, there's only 2 electrons that are in the valence shell. So the outer shell is the valence shell of the atom. All right, the next atom, everybody, is what? Lithium. So we're going to put lithium here, and the atomic number is 3. And so we'll do this one again. (2p). Again, that's how our book does it, but it's not how everybody does this. So we're going to put in 3 electrons, and we can still, now we can use full arrows. That's my full arrow. It's not a very good full arrow. And we'll put 1 on the 2s. So when the arrow is pointing up, that's going to be clockwise. So always put them in clockwise first before you go counterclockwise, or before you go down. Now, long and short electrons. Now, electron configurations. Well, our long electron configuration is not hard. We know that to be 1s2, 2s1. So you read the diagram like a book. But on the short electron configuration, which won't look like much of a shortcut here, but because we're on lithium over here, you go back to the nearest noble gas. These are the noble gases in group 18. You go backwards, 3, then 2. This is the nearest noble gas going backwards. So we'll put helium in a bracket called the kernel of helium, and then finish up with the 3s1. Now the reason it's a shortcut, what if we were trying to write the abbreviation or electron configuration for rubidium? Well, then you have to go through all these guys, list them all, and then we get to rubidium. But it's a lot easier to put krypton in a bracket here and say the kernel of krypton, which means all the electrons that krypton has, and then add on this right here, which would be 1, 2, 3, 4, 5s1. So again, this region right here in groups 1 and 2, this is the S region. We've got the D block over here, the D block, and we have the P block over here. And the F block is down here. Yeah. We should have a lowercase d here, like that.
And the bottom is F?
And the bottom is F. These are the transition metals, the inner transition metals, rather, and up here we have the transition metals.
What's the one on the right?
This would be P, the P block. And again, there are 18 columns that go up and down the periodic table, and there are 7 rows or piers that go across horizontally. Now, so that's the reason why we're having the short electron configurations, is because when we get way down here, we need a shortcut. So here on lithium, we've done this. So we're going to put the kernel of helium here, and then 2s1. So when you say the kernel of helium here, that is 1s2, because that's helium's electron configuration, and then 2s1. So it doesn't look like a shortcut here, but it will be a shortcut. So So on the Bohr model, we're going to put our nucleus there. It's supposed to be a clumpy nucleus, and we'll put the Li there, the symbol. And how many energy levels will we have on this? Well, the 2, because the 1 stands for the first energy level, the 2 stands for the second energy level, or second circle. So we'll put 1 circle here. We've got our 2 electrons. Then we'll put a second circle. Now some people put them up and down this way. I go this way, because there's a method to the madness. And then for our dot diagram, we put lithium. And now we're going to use just the valence shell. So this outer shell is called a valence shell, which holds valence electrons. Okay, so we're just going to have 1. So I was trying to put the electron on the right side, but you might see them on top. Okay. Now, so if I went too fast, you guys can pause it and catch up. Now let's go to the next element, which would be number 4, which is beryllium. Now, for you guys at home, I would recommend you putting the headings up here. I just really didn't have time for this exercise. And this atomic, the atomic number is 4. Now let's use a different orbital diagram. A third kind of orbital diagram is like this: 1s, 2s, 2p. And the difference is, this is better because here you have low energy, and here you have high energies represented by the steps. So as we go, we're going to fill in these orbitals from low energy to high energy, and this is called the off-ball principle. Fill in the low numbers first, and then to the higher numbers. Okay, so we got 4, so we're going to do 1, 2, 3, 4. Again, we're following the Pauli exclusion principle, that only 2 electrons can occupy 1 orbital, which is a line, and they got to be spinning different directions, clockwise and counterclockwise. And now we'll write the electron configuration. We'll read it like a book: 1s2, 2s2. Now the short electron configuration, you'll have the kernel of helium, and then 2s2. And now the Bohr model, well, we're going to have our nucleus there, put Be in there, and then we're going to have our energy levels. And we have 1, 2, so we're going to have 2 circles or 2 energy levels. So in the first energy level, you have 2 electrons. That's all that first energy level will hold. It's just 2 electrons. Second circle, the second energy level, is a little bit bigger. It'll hold up to 8. But anyway, we're going to put in 2 right here, right and left. And our dot diagram can be like this. Okay.
1s2, 2s2, and then you went to
Right. This is the long way, and towards the, when we get further in the periodic table, it will be very long. And this is the short way, where we're using the nearest noble gas going backwards. Okay, and you have to know both ways equally, because on tests they do this just as much as they do this one. Any other questions to this point? Okay. Now, let's look at element 5. What is element 5? Okay, boron. Everybody, get out your periodic tables. I want you to have your periodic table handy, so you'll need this when we go through electron configuration. Now, let's look at what we've done so far. Here we have the first energy level, and it only has 2 elements here, 1s2. And lithium is on the second row, so it's 2s. This is s1. This is s2. So lithium is going to be 2s1. Beryllium ends in 2s2. And then we're going to pick up with the p's over here. These down here are the D's, and we're skipping those because they don't go by the rules that the 1 and 2 and groups 18 through 12 do. And they're also called main block elements, main group elements, both names, for groups 1 and 2 and 12 through 18. So anyway, we have how many protons, everybody? 5. Okay, and we're going to do our diagram the same way again. 1s, 2s, 2p, and how many electrons will we put in here? 5. Now you guys feel free to chime in and answer. You know. So anyway, so we got 1, 2, 3, 4, 5. So again, this is low energy going to higher energy. You're feeling low energy first. That's the off-ball principle. Now the electron configuration, read it like a book. 1s2, 2s2, and 2p1. Now the short electron configuration, you go to boron here, and you go backwards to the nearest noble gas in group 18, and again, you're at helium. So you're going to put helium in a bracket, which is 1s2. Then add on the second period, the next period, as 2s2, 2p1. 2s2, 2p1. Questions about so far on boron? Okay. Now let's do the Bohr model. Put the big B there. And we've got 2 energy levels. And we're going to put 2 electrons on our first energy level. That's all it can hold. On the second energy level, we have 2 plus 1 makes 3. Right, left, up. Now, I hope you guys are making circles better than I am, because I don't draw very well. And so we put the big B here. And are we going to put all the electrons on the outside? The valence electrons. Which shell is the valence shell, everybody? The last one, the outer one. So we're going to put 3 electrons here. 1, 2, 3, like that. That shows, it's a short way to show what boron brings to the party. Okay. Now the next element is what? Carbon. Okay, and we'll do this one more time. 1s, 2s, 2p. This is really the best way to do this, and the only problem is it gets pretty long when you go up the periods in the periodic table. So we're going to put in 6 electrons. 1, 2, 3, 4, 5, 6. Well, looky there, we did something different. So here, when we have orbitals of equal energy, we're going to put 1 electron in each before we give one too. It's like if you had triplets. You want to give each baby a little something before you give a baby more than a little something. We call this Hund's rule, aka the candy bar rule, where if I came in with a couple bags of candy, it's right for me to give everybody 1 candy bar before I come back and give you guys 2, right? Although I might want to give Justice 2 because she's giving all the answers here. Okay, so we got 1s2, 2s2, 2p1, and I'm sorry, 2p2. Okay, so again, the short way, we have the kernel of helium, and then 2s2 and 2p2. We're going to put carbon here. Now I'm soon going to let you guys go on with this, because I'm just going to do this for up through neon, and then I'm going to let you guys go with this. So we're going to put carbon there in the middle of the nucleus, and again we have 2 energy levels, 2 electrons. Now on the second energy level we have 2 plus 2, which is 4. Right, left, up, and down. Then we put.
Why isn't there 3 energy levels?
Why is there what now?
Why is there not 3 energy levels?
S.
Yeah.
S is the same energy level. 1s and 2s.
Right, because these are. Well, 1 means the first energy level. It just means the first circle here. 2 means the second circle. Okay, and you've got two shapes of orbitals. You have the S-shaped, which is like a softball, and P-shaped, which is like a dumbbell. But you add them together on the second energy level. So this second energy level will hold up to 8 electrons total. So, and you've seen this a lot for carbon. You've seen carbon look something like this a lot. It loves to make bonds with itself. We have carbon all throughout our body, long chains of carbon. Okay, now let's go to the next element. So that's going to be nitrogen, which would be 7. And I'll just go back here to the way this book does it, 2s, 2p. So I want you to be able to recognize it every single time you see it. 1, 2, 3, 4, 5, 6, 7. So again, what rule do we call this?
Hund's rule.
Hund's rule. Okay, and so when we write this out, 1s2, 2s2, and then what, Abby? 2p, 2p3. Okay, and what will be, Trey, what will be our short electron configuration? So we'll call it the kernel of helium.
Then 2s2 and 2p3.
Okay, good. And we're going to put a nucleus here and put N there. So Hector, how many circles or energy levels am I going to put around the nucleus of nitrogen? How many circles or energy levels? So you can read this out here. You see 1 here, that's 1, and then this is 2. So we'll put 1 here, which still has that 2 electrons. Then the second energy level, which now has 5, right, left, up, down, then. And we'll put nitrogen as the dot diagram here, right, left, up, down, then. Any questions so far? Okay, this is really pretty easy stuff. And all my classes have liked doing this. They would make 100 on the quiz that I'd give them. I'd ask them to do any 4 that I pick, and they love it. We're going to go through neon, then you guys are going to finish through calcium, and then we'll do some more tomorrow. Okay, so we're just on nitrogen, so we're going to do oxygen here, the big O, atomic number of 8, and then we'll just go back to the first way we did this, which is the way that everybody wants to do this because it's easy on the space. So we got 1, 2, that's the Pauli exclusion principle, 3, 4, and then 5, 6, 7, and now we come back and double up. So again, this was higher energy here and low energy there. So you're still thinking from low to high, which is off-ball principle. Okay, or the off-ball principle. So let's go ahead and write our electron configuration. Will, what would that be? So write the 1s.
Oh, okay. Yeah. Let me do the
So you're going to read it like a book. 1s2.
1s2, 2s2, then
2p4. Okay, Nick, what about the short electron configuration?
HE, I believe, and then 2s2 and 2p4.
Okay. And now we want to draw the Bohr model. Put to big O in there. And we still have only two main energy levels.
Screen turned off.
Okay. Let's see here. There we go. All right. Well, it still may be recorded. We'll see how it goes here. So we got two electrons here like this, and then we got 6 right, left, up, and down, then go, like that. And then we're going to write our dot diagram, the big O, and put our valence electrons, like that.
Mr. Long?
Yeah. Yeah, I understand.
Oh, okay.
Why don't you guys go ahead and do the next one, fluorine. Fluorine.
Do you want us to go to calcium?
Well, it's still here. So let's do, yeah. So the next one after oxygen is fluorine. So we'll do that. Number 9, and we'll still go on this easy way. Okay. And then we're going to put in 9 electrons. 1, 2, 3, 4, 5, 6, 7, Hund's rule, 8, 9. Again, you can put half arrows or full arrows. I want you to get used to seeing either one. Either one is correct. Okay. So, Cody, what's our electron configuration? Oh, sorry. What's our long electron configuration?
Our long is going to be 1s2, 2s2, 2p5.
Okay, and what's the short way?
HE. 2s2, 2p5.
Okay, and we're going to draw the Bohr model. So again, at home you guys can, I want you to write the headings here. So put the clumps of protons and neutrons, put the big fluorine there in the middle, and we still only have 2 circles. So on the first energy level we still have 2 electrons and it's filled. On the second one we got 2 plus 5 makes 7. Right, left, up and down, then go all. And we put the outer circle for the valence electrons. Like that. Now when you look at fluorine, see 8 is a magic number when it comes to atoms having the right number of electrons in the outer shell. 8 makes them stable. It's called the octet rule. So fluorine is very close to getting to 8 here. So as you can imagine, fluorine is very reactive. So the last one to complete this would be neon, number 10. Okay, so 1, 2, 3, 4, 5, 6, 7. That's Hund's rule. 8, 9, and 10. Don't you just think that neon is going to feel better when it has this all complete? He's going to be very stable. And we write this out. And again, on the short way, we're going to
Annie?
do what now?
Wouldn't you just do Annie since it's a number 1?
Well, you can't just do that. We're still going to use this, but and then the 2s2 and the 2p6. But on the very next one, on sodium, we're going to use a different one. Which element, everybody, will we use for the noble gas going backwards when we start sodium? Ne, neon. Okay, and so you're going to do this, put Ne there, and the second energy level, right, left, up, and down, then go all around. Okay. So neon completes the octet. It's stable. It doesn't want to play with others. It's a happy gas. And there we go. Now I want you guys at home to do sodium through calcium. So you'll start, the only thing different on sodium, you're going to have this now. You'll have 1s, 2s, 2p, 3s, 3p, and 4s. So it's going to get long. Okay, but that's really the best way to do this. So anyway, signing out, and I'll see you later.